So in part D of this question, we are told that now we remove the sphere and the test charge, and we have this rod of length 2L with a uniform negative linear charge density negative lambda. And we need to deduce this equation for the electric potential for some point P outside of this rod that is given by this equation. Let's say we have some point P over here. Then, well, what we can firstly note is that the potential is going to be, well, what we can say is that simply the potential is kq over r squared. So what we can say is that dv is equal to k over r squared times dq. And so v, if we integrate both sides, then v will be the integral of k over r squared times dq. And since we know the charge density, we can say that the charge density negative lambda is dq over dx. And so dx is equal to minus, so not dx, dy. So dy like this. And so what we can say is that dq is equal to minus lambda dy, which we can substitute into our equation. So what we have then is integral equal to the integral of k over r squared times minus lambda dy. Now the question is just what is r? So r is the distance between any specific point on our rod. This is r. From the 0 position, we have this defined as well yp. This is the y coordinate of point P, and this remaining distance is our y coordinate of the point we select on the rod. Therefore, we can say that r is simply, so we can continue this, so r is simply yp minus y squared times minus lambda, like this. So then this will simply be multiplied with dy as well. So we're integrating with respect to y, and we will have to integrate on the entire length of the rod, so from 0 to 2L. So if we integrate this, this will be the natural log. So if we write this down, then what we can say is that, well, this will be k times lambda, and then this will be multiplied with, well, if we integrate this out, this will be ln yp minus 2L, right? And then this will be so what we can say is that since we have ln yp minus 2L, then we can say this will be ln times ln of yp over yp minus 2L, just like this. And well, then we have the equation that we need. And then in part 2, we need to sketch the graph of the y component of the electric field resulting from the rod as a function of y. So, well, what we can say simply is that since it has a negative charge density, this rod, the electric field will also be negative, so we'll be pointing in the opposite direction, and simply according to Coulomb's law, it will approach the y-axis as it goes to infinity.